Okay, guys, this is Mrs. Lyons. I am going to go through this worksheet that we did today in class and then the homework. I apologize, the video that I made last night was not very good, so I'm going to kind of plug through this and get it done so you have it to look at tonight. Okay, a couple of notes that you should make on any worksheet, quiz, test that you're doing to make, or just make sure you know these things. Okay, so when we're talking about elements. Okay, so single atoms, single type of atom. Okay, so copper, hydrogen, oxygen, just one thing. Okay, they are all solids. Okay, except. Okay, so there's always got to be the exceptions. Okay, two of our elements are liquids at room temperature. Those are mercury and bromine. They are underlined on your periodic table. And then there's a handful of elements that are gases at room temperature. The ones that we will see are hydrogen, oxygen, nitrogen, fluorine, and chlorine. Okay, the noble gases are also gases at room temperature, but we will not be using those because they don't react. Okay, and then finally, we need to know the 7 diatomic elements. Again, elements, so it's just one type of atom, not a compound. Okay, and those are hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine. Okay, remember Hoberfinkel. And you can also, if you don't like Hoberfinkel, there are 7 diatomic elements. So if you start at nitrogen, which is element number 7, and you make a 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, that's only 6. So we have to remember that hydrogen is over here. It doesn't always end up where we need it. Okay, so let's go through these that we went through in class today. All right, synthesis versus decomposition. I'm going to make a little note up here. Synthesis is when we have 2 elements. Okay, decomposition is where we start with 1 compound. Okay, so if you look at these, we have 2 elements, synthesis. We have 1 compound, decomposition. We have a compound, decomposition. A compound is when we have 2 or more elements bonded together, so they're connected. Okay, lithium plus nitrogen, synthesis, 2 elements. Potassium plus fluorine, synthesis. And finally, FBr3, that's a compound, so decomposition. Okay, so now when we write these, okay, I'm going to rewrite my reactants, okay, magnesium, and I want to include the states of matter, okay, so solid, liquid, gas. So magnesium is a solid, okay, remember here's our list. All elements are solids except these, okay. So we have magnesium plus O2, oxygen, which is a gas. Okay, it's on that list. Those react to give us, I need to grab a piece of paper, hold on. Those react to give us a compound. And in order to figure out the compounds, okay, you have to combine the elements and crisscross the charges. And when I say crisscross the charges, you should have your periodic table labeled so that everything in group 1 forms a +1 ion, everything in group 2 forms a +2 ion, everything in group 13 forms a +3 ion. We don't really deal with group 14. Group 15, everything forms a -3 ion. 16 is a -2. 17 is a -1. The middle, remember, those are transition elements. The only two in the middle that you will need to remember are zinc. I'm going to highlight these. Okay. Zinc always has a +2, and it says it right there. And silver always is a +1. Okay. So let's look at what this means. All right. So if we have magnesium and oxygen, I'm going to look at my compound is going to be MgO. I can't just stop there. Okay. I have to look at my periodic table. Magnesium has a +2 ion. Oxygen right here. Oops. Oxygen has a -2 ion. So magnesium's +2, oxygen's -2. Remember, if we crisscross those, we would come up with Mg2O2. We are going to simplify every compound if it can be simplified. So this ends up just being MgO. Okay, and I am going to take a minute and balance this for us. We didn't balance them in class, but I want to give you another technique to balance that might be helpful. Okay, so I'm going to write this equation a little bit differently. I'm going to write, I've got Mg and I've got O2, and I'm going to write my O2 like this. Okay, just so that I'm showing each element, and then I make MgO. All right, so when I balance, okay, I have to have the same number on each side. So here I have 2 oxygens. Here I only have 1. The only way for me to get another oxygen is to draw a whole compound MgO. All right, so now I've got 2 oxygens, but I've also got 2 magnesiums. Okay, so I need to draw another magnesium. So now my coefficients, I have 2 magnesium, so 2 here. I have 1 O2, and I have 1, 2 magnesium oxide. Okay, all right, next one. And we're going to jump down. We're going to do all the synthesis first, and then we will come back to the decomposition, just so we kind of practice everything together. Okay, so lithium plus nitrogen. And I'm going to write this. Remember, I'm going to write, so I've got lithium. It's a solid. It's a metal. Plus nitrogen is N2. Nitrogen is a gas. Okay, I'm going to put those things together to form lithium nitride. Now, here's what I got to think about. Okay, I have to look on my periodic table. Lithium forms a +1 ion. Nitrogen forms a -3 ion. So lithium is +1, nitrogen is -3. I'm going to crisscross these, which gives me Li3N. All right, so that's my product here. Now, remember, I guess I didn't say this, but all ionic compounds, when we do this, are going to be solids for right now. Okay, so let's go ahead and try to balance this. And I'm going to do the same thing I did for that last one. So I've got a lithium plus 2 nitrogens connected, and then I have 3 lithiums connected to a nitrogen. Okay, so let's see. I have, let's see, where do I want to start? And you can start anywhere. I'm going to start with the compound. Okay, I have only 1 nitrogen here, and I have 2 nitrogen here. So in order to have 2 nitrogen, I need to draw another one of these. Okay, so now I have 2 nitrogen, 2 nitrogen. I also have 1, 2, 3, 4, 5, 6 lithium. All right, so now if I want to put in my coefficients, I have 1, 2, 3, 4, 5, 6 lithium. I have 1 N2, and I have 1, 2 Li3Ns, lithium nitrides. All right, And then we're going to do this last synthesis reaction. We have potassium plus fluorine. So potassium, K, is a solid, plus F2 is a gas. All right. When those react, they're going to form a compound made of potassium and fluorine. Okay. If I look at my periodic table, potassium has a +1 charge. Fluorine has a -1 charge. Those balance each other out. So our product is just going to be KF, potassium fluoride, and that's a solid. All right. So if we want to balance this, okay, I have a potassium plus 2 fluorine react to give me KF. Okay. Here I've got 1 fluorine, here I've got 2. So I need a second one of these to give me a second fluorine. That also gives me a second potassium. Okay, so I need to add a second potassium here. And then I'm balanced. All right, so I've got 2 potassium, 1 fluorine, and 2 potassium fluoride. Okay, so that's synthesis. So let's switch gears and let's talk about decomposition. All right, in decomposition, okay, what you're going to do, all right, so in synthesis, we were combining the elements and crisscrossing charges. In decomposition, all we have to do is separate the elements in the compound and decide if any of them are diatomic, which means that they would have to have a subscript of 2. And then we figure out the states. Okay, so those are the steps for doing a decomposition reaction. So this first example, we have NH3, which is ammonia. And I tell you that that's a gas, so NH3 gas, okay? It's going to break down to nitrogen plus hydrogen, all right? The only thing you have to check is to see if these elements here are part of the 7 diatomic elements, the Haber-Finkel 7. And if we look, nitrogen is, and so is hydrogen. So that means N gets a 2, nitrogen gets a 2, hydrogen gets a 2. They are both gases, so we put a little G behind them, okay? All right, so now we're going to balance, all right? So I'm gonna do the same thing. I have N, H, H, H plus, oops, no, not plus, reacts to give me NN plus HH. Okay, so let's see. If I look, I've got 2 nitrogen here and only 1 nitrogen over here. So I'm going to go 1. I've got to add this whole thing. All right, so now I've got 2 nitrogen on each side. 1, 2, 3, 4, 5. I've got 6 hydrogen. Here I've only got 2. So I'm going to draw 1 more of those, gives me 4 hydrogen. If I draw a third one, I have 6 hydrogen. Okay, so I balance that. I have 2 NH3s, 1 N2, and 3 H2s. Okay. All right, let's look at the next example. All right, so in this case, we have water, H2O. All right, so H2O, if we're talking at room temperature, H2O would be a liquid. It's going to decompose to give us hydrogen plus oxygen. All right, both of those are part of the Haber-Finkel 7, meaning the 7 diatomic elements, so they both get a 2, and they're both gases. Okay, Now, I'm going to show you a little bit different way to balance, okay? The tally method. All right, the tally method has us write down and make a list of the elements that we have. In this reactant water, I have 2 hydrogens and 1 oxygen. On the product side, the right side, I have 2 hydrogens and 2 oxygens. All right, so I'm short an oxygen over here. So I'm going to put a coefficient of 2 in front of the water. Okay, now what that does is it gives me 2 times 2 is 4 hydrogen and 2 oxygen. Okay, so my oxygen are balanced, but my hydrogen are not. I've got 2 here and 4 there. So I need to put a coefficient of 2. So 2 times 2 is 4. And now we have a balanced chemical equation. And I am going to put the 1 in there just to show I'm done. All right. Last one on this sheet. FeBr3. All right. So FeBr3 is a solid because it's ionic. When it decomposes, it's going to form iron plus bromine. Bromine is one of the 7, so it's a diatomic element. And bromine is actually a liquid, okay? So, and iron is a solid. All right, so let's balance this. All right, so this one, I have iron and I have bromine, okay? On this side of the equation, I have 1 iron, 3 bromine. On this side of the equation, I have 1 iron, 2 bromine. Okay, now this is a type of a balancing that you're going to see lots of. Okay, you need to just kind of get familiar with this pattern. Okay, when we have 2 on one side, 3 on the other, we need a common multiple of 6. So to get 6 bromine here, I would have to multiply this compound times 2. So that's going to give me 2 iron and 2 times 3, 6 bromine. Okay. Over here, I have Br2. I'm going to have to put a coefficient of 3 here. 3 times 2 is 6 bromine. And then I only have 1 iron, but that's easy. If I put a 2 here, that balances my iron. Okay? So that is the process of predicting products and balancing. I'm going to skip these 3. We did them in class, but I'm going to kind of hold off on those because I do want to get this video posted. So I'm going to jump over here to the back and I'm going to work through all of these problems for you. All right. So what I want you to do is you're going to start by writing out the reactants. Okay. So in this case, we have calcium, which is going to be a solid, plus oxygen. Okay, oxygen is one of the Hober-Finkel 7. So when it's by itself, it gets a 2. Oxygen is a gas. Okay. That is going to react to produce calcium oxide. Okay. Now, we can't just leave it at CaO. We have to look at the charges. So from our periodic table, calcium is a +2 ion. Oxygen is a -2. So in this case, and this doesn't happen very often, these balance out, cancel out, and our product is just CaO. Okay, so, and that's going to be a solid. Okay, and that's that way because the charge is canceled. All right, now if I want to balance this, and I want to do this one just by what I call as inspection. Okay, if you look, I have 1 calcium and 1 calcium. Here I have 2 oxygen. Here I have 1. All right. If I put a 2 here, now I have 2 calcium and 2 oxygen. All right. So my oxygen is balanced. My calcium is not. But it's pretty basic. If I put a 2 here, that changes that to 2. And now I'm balanced with coefficients of 2, 1, 2. Okay. All right. By the way, synthesis or decomposition. Hopefully this is easy peasy now. This is a synthesis because we're reacting two elements together to form a compound. All right. Letter B, copper plus sulfur. So another synthesis. All right. Copper. Now this says it forms a +3 ion. That's for us to use on the other side of the equation. You don't need to know that right now. Okay, because copper is an element. Copper is Cu. It's a solid. All right. It's going to react with sulfur, so S, which is also a solid. Notice those are both elements. Neither one of them is part of the 7 diatomic elements, so they don't need subscripts of 2. All right. So when we combine those, all right, we're going to get a compound that is, and I'm going to write this over here because I've got room, copper sulfide. All right, but we got to look at our charges. Copper is +3. Sulfur, if you look on your periodic table, is -2. So now if we crisscross those, we get Cu2S3. Okay. To balance this, okay, we can do this one by inspection too. Okay, some of the harder ones will have to maybe do the tally, but if you look at this, we've got 1 copper. Over here, we've got 2 copper. So that's pretty straightforward. I can just put a 2 there. Okay, because of this plus sign, that 2 only applies to copper. Something else I noticed, you have to include the plus signs between your elements when it's 2 elements reacting to form a compound. Okay, and then let's see. We have 3 sulfur. So if I do that, in this case, that equation is balanced. So that worked out pretty nicely. All right, let's look at letter C. Okay, so we have lithium, which is a metal, plus nitrogen, which is one of the Haber-Finkel 7 diatomic elements, so N2. It's also a gas. Reacts to produce, all right, I'm going to go all the way over here. Lithium is +1 when it forms an ion. Nitrogen is -3 when it forms an ion. So if I crisscross, I get Li3N as my product. Okay, so Li3N. Okay, I think I'm going to balance this. Oops. Hold on, my phone's ringing. Hold on. All right. I'm still at school and my kids think I should be home, so they're calling me. Sorry about that. Okay, so back to this. I'm gonna write this one out because this one is a little bit, maybe a little tricky. I guess we did one just like this, maybe this exact thing on the other side, but that's okay. So I have lithium and I have nitrogen. On my reactants, on the left side, I have 1 lithium and 2 nitrogen. On the right side, I have 3 lithium and 1 nitrogen. Okay. Rule of thumb, if possible, balance your compounds first. Leave the solo ions till last. Okay, so lithium and nitrogen, we're going to balance. We're going to see if this needs to be changed. Okay, so I've got 3 lithium. Over here, I've got 2 nitrogen. Over here, I've only got 1. So I need to put a 2 here. Okay, so now, I'm going to use my other pen. Now I have 6 lithium and 2 nitrogen. So my nitrogen is balanced. My lithium, not so much. But that's easy enough. I can just come over here and put a 6. And that gives me 6 lithium. So now I'm balanced. And I'm going to add that 1 just to show that I'm done balancing. All right, hydrogen chloride. All right, HCl. I didn't put this, but I should have. We're going to say that's a gas. You would not know that. That's not expected for you to know. That is, okay, so by the way, C was a synthesis. This, since we're starting with one compound, is a decomposition. Okay, so HCl decomposes into the two elements that make it up. Don't forget the plus sign in between. All right, then we have to look when we do decomposition, are these part of the Haber-Finkel 7, the 7 diatomic elements? Yes, they both are, so they both get a 2. And they're both gases, hydrogen gas, chlorine gas. Okay, this one, if you look, I have 2 hydrogen, 2 chlorine. Over here, I have 1 of each. So that one's pretty straightforward to balance. If I just put a coefficient of 2 out there, I'm good. Oops. Well, I'm good until I do that. Sorry about that. I wanted to put 1s there to show that I was balanced. So let's try that again. 1, 1. Okay, so I'm balanced. All right, silver and sulfur. I think I mentioned it to all of the classes, but silver always forms a +1 ion. Okay, so when we write this, this is silver plus sulfur, so that's a synthesis. So I'm going to have Ag plus S. Both of these are solids. Neither of them are part of the Haber-Finkel 7, so we just have Ag plus S. All right. When we make a product, so silver is always +1. You've got to remember that. Actually, you've got to remember it, but it is, if you look at your periodic table like I showed you a minute ago, it is there on your periodic table. Okay, so silver is +1. Sulfur makes a -2 ion. So if I crisscross those, I get Ag2S, solid. All right, now let's see, is this balanced? It's not balanced, but this is another one of those sweet ones where it's like we've got 1 sulfur, 2 silver, 2 silver. So balancing that one was pretty easy. All right. Letter F. Ooh, this one is a fun one. Okay. Aluminum plus oxygen. So that's going to be synthesis. So I'm going to start out aluminum, solid, plus oxygen. It's part of the Haber-Finkel 7. So O2S are going to react to give me aluminum oxide. I got to look at charges. Aluminum forms a +3 charge. Oxygen forms a -2. So if I crisscross that, I get Al2O3. All right, ionic compound. So it's a solid. I'm going to do this one because this one's a little bit this one's a little rough to balance until we really get good at balancing. So let's look at this. I'm gonna actually draw these out. So I've got aluminum plus O2, like that. Produces aluminum, aluminum, oxygen, oxygen, oxygen. So this is kind of an alternative to drawing the shapes, but it's a way to model. Okay. Now, if I look at this, again, I'm not going to look at aluminum first. I'm going to see my oxygen. I have 3 oxygen over here. I only have 2. So I'm going to add one of these. Now I have 4 on this side, 3 on this side. So I need another one of these. So A, L, O, O, O. Now I have 1, 2, 3, 4, 5, 6. If I draw one more of these, 1, 2, 3, 4, 5, 6, I've got 6 oxygen on each side. And I've got how many aluminum? 1, 2, 3, 4. So if I draw 3 more aluminum, now I'm balanced. So that means my coefficients are 1, 2, 3, 4 aluminum, 1, 2, 3 oxygen, and 1, 2 Al2O3. All right. Hopefully this is starting to get easier. I hope. All right, magnesium nitride. This only has 1 compound, so this is going to be a decomposition. All right, magnesium nitride. Magnesium, if you look at your periodic table, has a +2, forms a +2 ion. Nitrogen forms a -3. So if we crisscross those, we get Mg3N2. 2. It's going to be a solid. If that decomposes, I'm going to form magnesium solid plus nitrogen. Nitrogen is one of the Haber-Finkel 7, so N2, and that's a gas. All right. Let's see. This one's not so bad to balance, because if you look, you've got 2 nitrogen here, 2 nitrogen here, so that's good. Here, you've got 3 magnesium. I put a 3 there. Voila, I'm balanced. I'm going to plug in these 1s. Okay. All right. Letter H. Iron 2 chloride. I know that looks weird. The font won't let you put them together, so that's just a Roman numeral 2. Okay, so if I want, notice I've got iron chloride, so that's a compound, so this is going to be a decomposition. So I've got iron. This tells me the charge is +2. Chloride, Cl. I'm going to look here. Chlorine is in group 17, so it's going to have a -1 charge. If I crisscross charges, I end up with FeCl2, that's a solid, is going to decompose to give me iron, solid, plus chlorine. Chlorine is one of our 7 diatomic elements, so that's going to be Cl2, and it's a gas. Check it out. This one is balanced just the way it is. I love those. All right. Silver oxide. So this is a compound. It's going to decompose. It's going to be a decomposition reaction. Okay. Silver in compounds always has a +1 charge. Oxide. Okay, so let's just look at that. Silver +1. Oxygen forms a -2 ion. Whoops. If I crisscross these, I get Ag2O. All right. That is going to decompose to give me silver plus oxygen. Silver is a solid because it's a metal. Oxygen is one of the Haber-Finkel 7 diatomic elements, so it gets a subscript of 2. Oxygen is a gas. All right, so let's see. How does this one balance? We might have to take a minute on this. Let's do the tally method. So AgO. On this side, I have 2 silver, 1 oxygen. On this side, I have 1 silver, 2 oxygen. Yeek. So let's see. I have 2 oxygen over here and only 1 over here. So what do I need to put here? I need to put a 2 here. That gives me 2 oxygen now, and 2 times 2, 4 silver. All right. So my oxygen is balanced, my silver is not, but if I just put a coefficient of a 4 there, I now have 4 silver, and my equation is balanced. Okay. We're almost done, guys. We're going to make it. All right. Zinc oxide compound. It's going to be a decomposition. Zinc always forms a +2 ion. Oxygen has a charge of -2 when it's an ion. Those are going to cancel out. So zinc oxide is just ZnO, solid. And it's going to decompose to form zinc plus oxygen. Zinc is going to be a solid. Oxygen is one of the Haber-Finkel 7, so it gets a 2, and it's a gas. All right. Let's see. Can we balance this one? I need 2 oxygen and I only have 1. So if I put a 2 here, I now have 2 oxygen. I also have 2 zinc. So if I put a 2 there, I'm balanced. I can't emphasize enough, you guys, this plus sign separates the elements. Okay. So when I put 2 in front of zinc, it stops at the plus sign. So that 2 doesn't apply to the O2 over here. Okay, so that's just one of those things you got to kind of get used to. All right, last one. Magnesium phosphide. That's a compound. It's going to decompose. All right, so magnesium forms a +2 ion. Phosphide is phosphorus, so that's a -3 ion. if we crisscross, we end up with Mg3P2, solid because it's ionic. That is going to decompose to give me magnesium plus phosphorus. Now, neither one of those is part of Hoberfinkel, so they don't get a 2. And those are both solids. And this one's pretty easy to balance too, because we have 3 magnesium here, so I can put a 3 here. I have 2 phosphorus here, so I can put a 2 there. All right, guys, I hope you look at this. I hope it helps. We will keep practicing. Practice is going to make perfect. I will see you in class.